All right, so guys, we have a question on Chebysheve polynomial, and we have to prove the integral, and we have three different conditions in proving the integral. So we have the first condition is when n is equals to m. The second condition is when n is equals to m and it is equals to 0, and our answer is pi. And lastly, we have the third condition. Now, to solve this polynomial, now look at this integral. If you look at this integral very well, you notice that it is a substitution integral, and if you are very conversant with your integration, you know that the best substitution in solving this integral is by substituting s equals to cos. So if s equals to cos theta, this simply means that our dx is going to be minus sine theta d what. Let us not forget this is an integration, so we have the c2. Now, if that should be the case, it simply means that if we are taking Tm of s, and we already stated that s to be cos theta, so it means that we have this to be Tm and x is cos theta. This is going to be what? Cos theta, and this is going to be cos theta. So that should be the case. Likewise, if it is also Tnx, we have Tn cos theta, which is equals to cos theta. Now, from equation 1, you notice that you can make theta the subject of the formula. If you make theta the subject of the formula, theta is to be inverse cos of x, make theta the subject of the formula. So, but this expression we have over here will be useful for us when we are solving integration and when we are solving some other proofs of Chebysheve polynomial. So let's go on. But we have to change the boundary. You can see clearly that our boundary is from -1 to 1. So, and we have a substitution that s equals to cos theta. So when s is equals to 1, what would be the value for theta? Or let's start from -1. Let's start from the lower limit. When s is -1, what is going to be the value for cos theta? If theta is subject to the formula, you have cos inverse of what? Of -1, and the answer for this is 180 degree. 180 degree is still the same thing as what? Pi. Now, similarly, when s equals to 1, we have 1 is equals to cos theta, and theta will be equals to cos inverse of -1, and cos inverse of -1 is what? Is 0. So we can now rewrite our integral by substituting its boundaries. So we rewrite our integral. Our integral becomes integral of -1 to 1 over square root of 1 minus squared dx plus tx dx. We can write it as integral of pi to 0, and tnx is already, the first one is cos n theta multiplied by theta over square root of 1 minus x is already cos theta, so that's 1 minus cos squared x multiplied by dx. Dx is minus sine theta. We have successfully rewritten our integral to this format. So we simplify. So on simplify, we have this to be equals to integral of we can change the boundary. If we change the boundary of this, we apply a negative sign. So the negative sign is going to cancel the negative minus sign over here. So we have 0 to pi 0 to pi now. Then cos m theta, let's write m theta and cos n cos. Don't forget 1 minus cos square theta x is the same thing as sine theta. So this over will cancel what we have here. So we are left with all of these but theta. So we can go ahead and solve that. Don't forget we have a rule in trigonometry that says that when you have cos a plus b, cos a plus b multiplied by cos a minus b, the answer is 2 cos what b. If we make cos a cos b the subject of the formula, you divide this by 2, you divide this by 2, so we'll be left with cos a cos b, cos a cos b equals 1 over 2 cos plus b cos a minus b. So that's what we'll have over there. So on substituting what we have, we'll be having integral. Let me shift it up. We'll be having the integral of 0 to pi cos m plus n theta cos m plus n theta plus cos m minus n theta. So that's what we'll be having over there. Multiply by, don't forget we have 1 over 2 here. Everything was theta. So when we integrate this, we have our answer to be cos m n, sorry, we will not have, we have sine m plus n over m plus n plus sine m minus n theta over what m minus. So that is what we have. But don't forget we still have our boundary 0 to pi. We still have our boundary 0 to what? 0 to pi. So on putting our boundary 0 to pi, you notice that pi, sine pi, if you put theta to be equals to pi, sine pi is 0 and sine 0 is 0, sine 0 is 0. So if that should be the case, we'll be left with, if you put pi over here, you have 1 over 2 here, you have 1 over 2 multiplied by what? 0. This is 0 and inside 0, which is the first part of the proof. We have successfully proved the first part. So let me quickly scroll so you see that we've proven the first part. So the first part over here, when n is equals to m. Now the second case is when n is equals to m and it is equals to 0. Now look at what we have over here. This point, let's say this is equation star. Equation star is what we're using every other ones that we have. So if that should be the case, when n is equals to m, n is equals to m and is equals to 0, what are we going to have? Definitely everything here will be, everything over here will be cos 0. Do you understand? Cos 0, and cos 0 will be equals to theta. Cos 0 is 1. So we have case 2, when n is equals to m is equals to 0, we'll have integral of 0 to pi, and this is going to be cos 0. Cos 0 theta, cos 0 is 1, 0 to theta, and the answer for this is theta. And if you put your boundary 0 pi, our answer is pi. So that is for case 2. Now going to solve case 3. 3 is when you have when n is equals to m, but it is not equals to 0. When is equals to, it is not equals to 0. So that is case 3. So you have from that equation star that we have up from the equation star. Let me quickly show you the equation star again. From this equation star, we apply, we say that when n is equals to n and it is, they are not, but they are not 0. So we'll be solving for this other part. So if n is equals to m, it simply means that we'll be having integral of 0 to pi cos squared n theta. So that is what we'll be having. And there is a rule in trigonometry. So cos squared theta, this is the same 0 to pi 1 cos 2n theta divided by 2 all theta, all the theta. So that is that for that. So we can factorize out 1 over 2. So we have over 2 integral pi and 1 cos 2n theta d theta. So once we have that now, if we integrate 1, the answer for integral of 1 is what? Is theta. The answer for integral of 1 is what? Theta. Of 1 with respect to theta is theta. So we have 1 over 2, get what? Open bracket, theta, and we have 0 to pi. Integrate this other one. If we integrate plus 1 over 0 to pi cos 2n theta dt. So any integral that you are integrating from pi or minus pi to pi, or any integral that is periodic in nature, the answer is automatically 0. So there's no even point integrating this. But if you integrate this at the end of the day and you put the value, you still have 0. You understand? You still have 0. Or the alternative way of doing this is the answer for this is pi over 2 plus integrate this. You have sine 2n over 2 over 2. So if you put theta to be pi, you have 0. 0 minus 0 is what is 0. So that is that for that. So our final pi over 0 is equal to pi over 2. So we have successfully proven the 3 laws, the 3 rules guiding this Chebysheve. So watch out for the other videos where other proofs are being discussed. Thank you very much.